bond bushing is required by code. Refer to 2020 NEC 250.70 cone, which states that service conductors entering buildings shall be grounded by connection to the grounding electrode system at both the service equipment enclosure and at the service point. Informational note number 1 to 250.70 cone clarifies that connection of the service conductors to the grounding electrode system at the service point may be made to the neutral conductor in the case of combined neutral grounding electrode systems, or by a grounding conductor connected to the grounded service conductor. The bond bushing provides a connection between the grounding electrode system and the grounded service conductor at the service point. In this specific scenario, the service point is the bottom of the meter socket. Without the bond bushing, the grounding electrode system would not be connected to the grounded service conductor, and consequently, the service conductors would not be properly grounded. This lack of proper grounding constitutes a violation of 250.70 cone. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This low impedance path facilitates the operation of overcurrent protective devices such as circuit breakers or fuses, which then energize the faulted circuit, thus preventing electrical shock hazards and minimizing equipment damage. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes, bonded together to form a comprehensive grounding network. The grounding electrode conductor connects the grounding electrode system to the service equipment enclosure and, in this case, also needs to be effectively connected to the service point via the bond bushing. The grounded service conductor, often the neutral conductor, is intentionally connected to the grounding electrode system. This connection ensures that the voltage between the grounded conductor and earth is maintained at or near 0 volts. This helps to stabilize the voltage and provides a reference point for the electrical system. Bonding refers to the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed. Bonding is crucial in reducing the impedance of the ground fault current path and providing the capacity to carry fault current. A bond bushing is a specialized type of fitting used to provide a reliable electrical connection between a metal conduit or fitting and a metal enclosure. It's designed with a sharp edge that bites into the metal surface of the enclosure, ensuring a low impedance connection. This is especially important when dealing with service entrance conductors, as these conductors carry the full fault current during a ground fault. The Myers hub is a type of conduit fitting used to connect conduit to an enclosure, providing a watertight seal. When a Myers hub is used to connect conduit to a meter socket or service equipment enclosure, it's essential to ensure that a proper electrical connection is established between the conduit and the enclosure. Without a bond bushing, the connection may not be sufficient to carry the fault current safely. In the scenario described, the offset nipple connects the Myers hub on the main disconnect enclosure to the bottom of the meter socket. Since these are service entrance conductors, it's imperative to have a low impedance ground fault current path. The bond bushing ensures this path by providing a direct electrical connection between the conduit, the Myers hub, the meter socket, and the main disconnect enclosure. The NEC mandates that all electrical equipment be installed in a neat and workmanlike manner according to 110.12. This includes ensuring that all connections are properly made and that all fittings are securely installed. A properly installed bond bushing contributes to a neat and workmanlike installation by providing a secure and reliable electrical connection. The NEC also emphasizes the importance of maintaining the integrity of the grounding system throughout the electrical installation. This means that all components of the grounding system, including grounding electrodes, grounding electrode conductors, bonding jumpers, and bond bushings, must be properly sized and installed to ensure effective grounding. The size of the grounding electrode conductor and bonding jumpers is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. The grounding electrode conductor must be sized to carry the maximum fault current likely to be imposed on it. Bonding jumpers must be sized to provide a low impedance path for fault current to flow back to the source. The NEC also addresses the installation of grounding and bonding equipment in specific locations. For example, 250.92b requires that metal enclosures containing service conductors be bonded together to form an electrically continuous path. This bonding is typically accomplished using bonding jumpers or other approved bonding methods. In addition to the general requirements for grounding and bonding, the NEC also includes specific requirements for grounding and bonding in specific types of electrical systems. For example, 250.30 provides requirements for grounding and bonding of separately derived systems, such as generators and transformers. These requirements are designed to ensure that separately derived systems are properly grounded and bonded to minimize the risk of electrical shock. The requirements outlined in NEC 250.70 cone and related sections are crucial for ensuring electrical safety and preventing electrical shock hazards. By providing a low impedance path for fault current, the grounding system helps to protect people and equipment from the dangers of electrical faults. The use of a bond bushing in the described scenario is a critical component of this grounding system, ensuring that the service entrance conductors are properly grounded and that the electrical system is safe and reliable. The installation of a bond bushing involves several key steps. Firstly, ensure that the surfaces of both the conduit fitting and the enclosure are clean and free of any paint, corrosion, or other contaminants that could impede electrical conductivity. Secondly, insert the bond bushing into the knockout of the enclosure, ensuring that the sharp edge of the bushing makes firm contact with the metal surface of the enclosure. Thirdly, tighten the set screw or other fastening mechanism on the bond bushing to secure it in place and ensure a reliable electrical connection. The tightening torque should comply with manufacturer's recommendations. After installation, it's important to visually inspect the bond bushing to ensure that it is properly installed and that there are no signs of damage or corrosion. Additionally, it's recommended to perform an electrical continuity test to verify that the bond bushing is providing a low impedance connection between the conduit and the enclosure. This test can be performed using a multimeter or other suitable testing equipment. If the continuity test reveals a high impedance connection, it may be necessary to retighten the set screw or clean the contact surfaces to improve the connection. In some cases, it may be necessary to replace the bond bushing if it is damaged or corroded. The selection of the appropriate bond bushing for a specific application depends on several factors, including the size of the conduit, the type of enclosure, and the environmental conditions. Bond bushings are available in a variety of sizes and materials to accommodate different types of conduit and enclosures. They are also available with different types of fastening mechanisms, such as set screws, spring clips, and compression fittings. The choice of fastening mechanism depends on the specific application and the available space. The material of the bond bushing should be compatible with the materials of the conduit and enclosure to prevent corrosion. For example, if the conduit and enclosure are made of aluminum, the bond bushing should also be made of aluminum or compatible material. In corrosive environments, it may be necessary to use bond bushings made of stainless steel or other corrosion-resistant materials. The NEC also provides guidance on the selection of grounding and bonding equipment. For example, 250.8 specifies that grounding and bonding conductors and connections shall be suitable for the environmental conditions. This means that the equipment must be protected from corrosion, physical damage, and other adverse conditions. In addition to the technical aspects of bond bushing installation and selection, it's also important to consider the safety implications. Electrical work can be dangerous, and it's essential to follow all safety precautions when working with electrical equipment. This includes wearing appropriate personal protective equipment (PPE), such as gloves, safety glasses, and arc-rated clothing. It also includes energizing the circuit before working on it and verifying that the circuit is energized using a voltage tester. If you're not comfortable working with electrical equipment, it's best to hire a qualified electrician to perform the work. Qualified electricians have the training and experience necessary to perform electrical work safely and correctly. They also have access to the tools and equipment needed to do the job properly. In conclusion, the use of a bond bushing in the described scenario is a critical component of the grounding system, ensuring that the service entrance conductors are properly grounded and that the electrical system is safe and reliable. The NEC provides specific requirements for grounding and bonding, and it's essential to comply with these requirements to ensure electrical safety. By following the recommendations outlined in this explanation, you can ensure that the bond bushing is properly installed and that the electrical system is functioning safely and effectively.